Now, for the central part of the flowers, we want to branch out from the circle that is copying the single petals. So take a scatter node, and we will go from the circle to the scatter. Here we want to scatter not 1,000, let's say 10 points. So basically we want to copy 2 points and take a line. We want to copy a line on these points, and if we merge the petals with these things now, basically we do have something like this. So first we want to randomize a little bit the length of these central lines. We want to take a point angle and quickly compute some p-scale value. So f at p-scale. We will fit01 the random function on the ptnum plus some seed that we can add to it. And we want to fit it between some minimum value and some maximum value. Let's say like this. And also let's declare some normal so we can randomize those. So 0, 0, 1. Let's click here to create this pair parameter. And let's say minimum 0.4, maximum 0.5, maybe also 6. Let's say something like this. And we also want to animate those. So let's multiply here everything for another channel. We will call this anim like the other one. And click here. Let's say from 50, it can be maybe half size, so 0.5. And in the end, 200, we can raise it to something like 1. Maybe the minimum is 2 minimum, let's say 0.5. And we also want to bend this line. So take a bend node and let's check if it is in the correct axis. It's not, so change the capture direction to the y-axis. And we also want to animate this bend. So we know that the line will stop growing at 200 frames. So let's say 150, it will be something like 5 degrees. And at 200, we can raise it, let's say, to 35 degrees. Of course, we need a few more samples on this line, so let's say 8. But now they are all oriented the same way. We can quickly randomize the normal with the just vector something, attribute adjust vector. Yeah, this one. We want to adjust the normal, and we don't care about the length. We just want to change the direction. We want to rotate it, and let's put it to 360. Also, we need to change to random and 0 to 360, and not on this axis but on the y. So we do have something like this, and let's check it. Yeah, it can work. Now we just need to add some spheres to the end of the lines. So on the line, we want to establish some group that will take the last point. So let's see how many points. And this actually are too many. Let's set the points to 6. So the last point will be point number 5. And we will call this group end. It will host only 1 point, and after the copy, only the last point. So we can take another copy 2 points, take a sphere for the left side, and set the sphere to be polygon, set the radius to 1, and maybe decrease the frequency, no, leave it to 2. And here, now we can adjust the uniform scale, and we want to target only the end group. So if we merge the lines and the sphere together, we do have something like this. The only thing, we want to apply some thickness to the lines, so drop down a polywire and set it to 003. Yes, and for the division we can maybe increase it to something like 6. We don't need the texture, so turn off do vertex texture. And finally, let's see if some cleanup is due, but doesn't seem that way. We want to clean the point group because we want to define two primitive groups. So delete this one and let's copy this group node. So this will be center spheres and this will be center lines. So if we merge everything together, we should have 4 groups. This should, oh, you need to delete only the point group. So yeah, we have the 4 groups and we just need to add the stem to the flower now. Maybe just decrease a tiny bit more the center spheres and basically the flower will be attached to the stem. So take another copy 2 points. This time the full flower will be the left input and the right will be the line for the stem. So something like this, but also this time let's make the line, let's say 8 points, and there's no need to do a group. Let's just delete everything except the last point. So select the last point, delete non-selected, and I don't know why half of the time the blast node doesn't work, but now we do have only one flower and we can animate the length of the stem. So if we merge the copy 2 points with the petal to the stem and the line before the blast, we do have something like this. We also want to bend the stem line, so take a bend and direction is on the Y, and if we increase the radius of the bend, and of course this needs to be also on the blast node, you can see that the flower is not orienting to the curve direction. So a quick fix is to take a polyframe node here, and this needs to be also before the blast. And here we don't want to compute this, we want to compute the tangent name with the normal name. So we are overriding the normal attribute. Now it is correct, but we need to rotate the full flower 90 degree in the X. And now, as you can see, we do have the correct behavior. And let's also create a null here for consistency. This will be out center. So now we want to animate the length of the line. So let's say at 50 it will be 0.1, put a keyframe on it, and at frame 200 it will reach the full length of 1. But this breaks a little bit the bend because the capture length stay fixed. So we want to copy the length here on the line and paste it on the capture length of the bend. So paste relative reference. So now we can animate the bend. So let's say at 200 it will be something like 60. And when it's just born, we don't want any bend at all. So let's say 0. So something like this. And we also want to animate the overall flowers here, right before the rotation. So let's say that 100, it will reach the full scale of 1. Let me hide this point, guys. And in the beginning, it will be half the size, so 0.5. Now, in my original setup, I had this little piece between the stem and the flower, but from this short distance and given the scale of the flowers, it really isn't noticeable. And since this video is just past the 3 hours and 20 minutes, I will say I will skip this part and we will close the stem with some thickness and then move on into the Copernicus part. So back into the scene, just take a sweep node so we can add some thickness to the stem. And let's see, reverse the cross section and let's set a radius of 0.016, I would say is fine. Also 8 as column, we don't need UV. And we need a group for the material of the stem, so this will be the stem. So we have all the groups we need. And take a final null, or rather 2, because I'm fucking compulsive, so out stem and out flower. Also maybe give it some normal before. So here we do have everything we need, and we want to write this as an USD. We will use this with a point instancer in Karma, so drop down a USD file export, plug it to the flowers, and here we want to say on the export tab we want the full range from 1 to 250, and I want to output the file in my job variable subfolder geo, and I will call this flower.usd. So I will cache out, or rather I don't need the final 50 frames, so let's say to 200, and you don't need to specify the frame number. The USD will export a single file with the whole animation. So click here, and let me just rename this guy, otherwise he will override my original one. And it should be already done. We can quickly check it with an USD file import. So here we want to target the USD file, and we do have the animation. We still don't have the group because we should unpack that after it, but we don't need to do it here. We will do it in Karma. And the last thing we want to do before moving on with the texturing is to create the scatter points for the flowers. So we want to take the branches BGO, it was this one, yeah, basically the secondary branches we generated within the tree, and we want to filter out the ones that have a low P scale. The problem is right now we don't have a P scale here, because if we go back to the tree, we did have a P scale here where we computed the length of the ID, but within the sweep node, we didn't say to carry on that P scale, because right here it say except P scale between a bunch of other attributes. So get rid of that. And before writing out, let's also keep the P scale, write the mesh. And if we go back to the flowers and we reload the geometry, we do now have some P-scale value, and it should be the consistent one. Let me make it as a color, rampant. And as you can see, it's pretty low. So let's see. Take a transform node and ghost the other geometry. So this was raised about 2.4, I guess. Yes, it does matches. Then compute some normals on the points. So like this. And now we want to take a delete node. So in here we can add a float parameter. We will call this threshold. And give it a name, apply and accept. Copy this parameter. Here we want to select delete by expression on the points, and we want to delete if the P scale is less than this threshold value. So paste relative reference. And now we should be able to delete, and we want to delete the non-selected. Also, let me adjust this range because the p scale is actually really low. So let's say 0.5. And we want to keep, let's say 0.02. This will be the branch that will scatter flowers. So take a scatter node, and of course here you can compute, density attribute and whatever. I will just scatter it as it is. I will start with 1,000. In the final version, we will do 10 times this. And then I want to take another adjust vector, so we can randomize the normal a little bit here. So adjust normal. We want to rotate it only. So rotate in a random manner, and I will say minus 35 and 35 is fine as it is. So just a little bit of randomization. Let's check the difference. Something like this. So finally take an attribute delete, so we can get rid of the p-scale. We will compute a new one for the flowers in karma, and also for the UV attribute. We don't need those guys, so let's keep the normals. And take a file cache. We do have some file cache here. No, we don't, so let's copy from the tree. Let's go back into the flowers. And let's call this flower pt, and we want to save the geometry. So just to see if it worked, let's take the USD import of the flower, and let's see if this scatter is correct. I mean, it is. We have a too big of a p-scale, but when we will define it, it will work just fine.